So we've got one girl pulling the toboggan this way and one girl pulling the toboggan this way. Now, if they were pulling at the same force and on the same angle, this would be no problem. It would just go in a straight line. But there's going to be somebody that's pulling harder than the other. So one's going to pull it up, one's going to pull it down, and we have to find out what that little bit of direction change occurs is. So this one pulls at 20 newtons, 30 degrees this way, and this one is 20 degrees and 15 newtons. But we won't take into account our friction force yet. The first thing that I want to do is I want to find out the applied force that these girls are pulling at. Okay, so to do that, I'm going to draw myself two simple triangles again in the direction that we're using. So this was 10 newtons, right? What was the bottom here?
Oh, 17.321.
321 newtons. Okay, so this is in a direction east, this is in a direction north. They'll use left, right, up, down. That's fine as well. Okay, now the other girl is pulling in this direction now. So 20 degrees, 15 newtons. Okay, and what was the downward force?
5.130 and 14.010.
Thank you. And that's east as well. Okay, so we know that they're both pulling in the east direction. That's the intended goal. That's the way the toboggan is going to go. But there is going to be a slight motion up or down because they're not exactly the same. So what I want to do then is my east motion, I just add my two vectors together. So that gives me 31.331, right?
Yeah.
And that's east. Oh, I gotta draw this down, sorry. I need to go north. Let's put it down here. 31.331 newtons. And that's east. Okay? I've got 10 newtons to the north and 5.130 newtons to the south, so I have to subtract those. Okay, and what does that give me? So 4.870 newtons north. So that's the little bit that they're going to go slightly upwards. Okay? I need my direction arrows now. I need my resultant force. That's my applied force right there. So using Pythagoras' theorem, 31.331 squared plus 4.87 squared. What do we get?
31.707.
707 newtons. Okay. Now I use second function tan, 4.87 divided by 31.31. And what is my angle?
8.825.
Okay. And that direction will be east, 8.835 degrees to the north. So now that I have my applied force, what is it that we learned about net force yesterday? How do I find net force?
Apply subtracts your friction.
Right. So my mass times acceleration is equal to my applied force minus my force of friction. All right? My acceleration then is equal to, I had 31.707 minus 8 newtons of friction divided by the mass, which was 20 kg. Therefore, my acceleration was equal to
1.185.
1.185 meters per second squared east 8.835?
Yeah.
35 degrees to the north. There's the entire question. That question is about, probably on the grand scheme of things, is probably the most difficult question you'll see on this section. Okay? And again, because I can do it all in right angle triangle trig, it shouldn't be that difficult. Shouldn't be that difficult. Okay?
So that's the hardest one, this unit's pretty rad.
Well, you should be doing better in this one than the others, right?
Right. Well, the last unit was a foundation for this unit.
Yes. That's right. Okay. Sample problem 3. So we didn't look at this one yesterday. A 40 kg wind sled is gliding across a frozen lake with a constant velocity of 12 meters per second to the east. Okay, so let's write out some of the information. 40 kg. Velocity is 12 meters per second, is that right?
Yes,
12 meters per second
to the east.
to the east. So I'll draw myself a little vector just so I know that I have direction involved. When a gust of wind from the southwest, okay, so my wind is from the southwest, so what direction is it going?
Northeast.
The wind's force is 100 newtons northeast, so I've got that. On its sails for 3 seconds, so the time this happens. So what you're going to see in this question right here is a combination of chapter 2 and chapter 3. We now have to work them all together and then utilize that information with chapter 4. So we're going back to those 5 equations again. We're going to use those 5 equations. We're going to use directions that we learned in chapter 3. And we got to piece this all together here. So it says, with what velocity will the sled be moving after the wind has subsided? So we need to figure it out then. Okay? So again, ground speed. Velocity of, in this case it'd be the sled. I'm going to say, I'll do this. Velocity of the sled plus the velocity of the wind. Alright? So with what velocity will the sled be moving after the wind subsided? So the first thing I need to do then is I need to find the acceleration. So I'm not going to use this. I'm going to use okay? So I've got V1, I got V2, and I have to work through my change in velocity. Alright, I'm just going to make sure I got this down so I don't confuse you anymore. Alright, so this velocity of this wind is going to act as my change in velocity. Okay, so that's what I need to get. Now I've got started with the force. So the first thing I want to find is my acceleration. How do I find acceleration when it comes to force?
Your net divided by your mass.
Yeah, my net force, in this case, which is 100 newtons, divided by my mass of my sled, which is 40 kg. So works out to 2.5 meters per second squared. So far, so good. Now, again, I have to use the triangle to help me here. So I'm going to get rid of this 100 Newton force for a second here. Get rid of that. And I'm going to change this to change in velocity, which I've already done. So how do I find change in velocity if I know acceleration in time? So acceleration is change in velocity over change in time. Change in velocity is acceleration times your time. So what's my acceleration?
2.5.
2.5 for
3 seconds.
3 seconds.
27.5.
So that's what I have right there, 7.5 meters per second, right there. So, I had to use the new stuff to get my acceleration. Then I had to use my old equation, acceleration is equal to velocity over time, to find out what my change in velocity is. Now, I have to use my equation of change in velocity to get my vectors. So how do I do that? Well, I need to get V2 here. So what is V2 equal to? In this equation right here. Change in velocity plus V1. Okay? Now, I can use components or I can draw it as is. So, if I draw it as is, change in velocity add my V1 that's what I have right there. That angle is 45 degrees. What does it make this? 135 degrees right there. Now I can use my law of cosines to get it. Okay?
How did you know that that was a 45-degree angle? Okay. Never mind.
Oh, I just question. See,
And we get, let's get our calculators out and work on this, please.
I got 18.098.
Okay? Now I need an angle. What's that angle?
.27 or 28 if you round up, but it's 27.960.
Okay? So my direction then is east. How much to the north?
Just 45 to take away that?
17.04.
All right. Okay? So a lot of work in this question. A lot of work in this question, a lot of information that we had to use from our previous section in order to do this. Okay, so let's go back and let's start this again. and just have a look as to what are some of the things that I needed to do. Okay, so the question gave us an initial speed of a sled traveling 12 meters per second to the east. It said a wind blew on it at a force of 100 newtons, and then it wanted us to find out what its new velocity was. So its new velocity is v2. So v2 is equal to your change in velocity plus your v1. So this equation right here helps us draw our vectors. But in order to get my change in velocity, I needed to first get my acceleration from force. So force divided by mass. And then I needed to use my time and my acceleration to get my change in velocity, which was right here. Once I had my change in velocity, I had my two vectors that I needed to draw out. Once I drew out my two vectors, then it was a matter of finding out what's the direction of the sled and the angle that it goes on. Okay? So those are the two questions that I think you'll find more complicated. All right. Any comments about that?
So we don't need to do that velocity ground because we don't need that one?
No, no. We just use change in velocity on that. Okay. This is a short section. There is not a lot to it. That's about all there is. There's one more little piece I'll save for tomorrow. But past that, that'll take us. There's like one more sample problem that I would show you. And that would cover it all, but I'll wait and leave that. So right now there's 10 questions. 5 on page 143 and 5 on page 138. And if you happen to finish that, there's 4 more questions on 147, but those are the 10 questions that you could do, you'll do today. Okay? So. And that's all there is. All right?
So we'll test the after break then?
Well, what I'm thinking is I might just give you an assignment
Instead of
before the break, and then we'll go from there. We'll see. I can combine this test with the next unit.
Would you able to make that assignment tomorrow then? I'm not here Tuesday.
Okay. You have the rest of today to work on that.
Can we listen to music?
Yeah, sure.